Measurement of earthworks. Earthwork in construction is all about preparing the land for a building or other construction project. Earthwork is one of the first steps in any construction project, and it is crucial for ensuring the safety and stability of the final structure. It is often done with heavy machinery like bulldozers, graders, and excavators. This involves excavation, cutting, filling, grading, and compacting. Therefore, in this video, we are going to explain step by step in calculating the earthwork. The requirement of calculation include drawing, taking of list, quarry list, measurements in dimension paper, and bill of quantity. This is one of the examples of the earthwork drawing. First, we need to list all the items in the taking of list by referring to the drawing. There are 3 items which we will calculate in the calculation. The first one is the excavation, stripping topsoil. Second is the excavation, cut and dispose earth. And the third is the filling general imported material. Next is the quarry list, which serves as a tool for the estimator or taker of to clarify any ambiguities or missing details in the drawings or specifications. When specific information is absent, assumptions need to be made to proceed with estimating the project accurately. These assumptions are documented in the quarry list, ensuring that both parties have a clear understanding of the estimator's interpretations and presumptions. Separately, the quarry list should contain at least 3 assumptions. In this calculation, there are 3 lists, which is the size, type, and grade of imported material, which are not given in the drawing.
Next, to calculate the average level. So, to calculate the average level, we will be referring to the grid that was provided in the drawing to find the average level at different points. This will help us to determine whether it needs to be cut or fill the excavated area. Firstly, the first column in the table is to identify the exact area we are measuring on the drawing. The next column shows the average ground level for each grid square. So, to find this average level, we add the height at each corner of the grid and then divide by 4. So, for example, in grid C1, the average height is 44 meter plus 45 meter plus 49 meter and plus 50 meter and divide with 4, which equal to 47 meter. Then, the next column shows the topsoil depth, which is 100 millimeter as specified in the drawings. This depth will be removed. To find the new average level, we subtract the topsoil depth from the average level in the previous column. The next column shows the proposed level, which is 49 meter according to the drawings. Therefore, we need to compare this with the value of new average level by minus the topsoil depth to see if we need to remove the soil or add the soil to reach the proposed level. Therefore, if the answer is positive, it means we need to add soil because the ground is lower than the proposed level. Then, this value goes in the fill column. But if the answer is negative, it means we need to remove the soil because the ground is higher than the proposed level. Then, this value goes in the cut column.
Let's proceed to the next step, which is the measurement of earthwork. It falls under class F. So, for the excavation work described under code F111.5 and 6, it involves stripping a 100 mm thick layer of topsoil, which will then be disposed off-site. In the measurement, we specify that the excavated material will be disposed of, and the thickness of the excavation is 100 mm. Moving on to the calculations, we will consider the area to be excavated. As you can see from the drawing, it contains 3 squares and 2 triangles that will be combined together to form a square. Therefore, we have a total of 4 square-like shapes. Now, to find the total area, we will multiply the number of square-like shapes by the width and the length of the grid. So, it will be 4 times by 5 meter width times by 5 meter length equal to the total area of 100 meter square. Next, for the excavation work described under code F131, it involves cutting and disposing earth materials to meet the proposed level. For each grid, the calculation is done by multiplying the width by the length of the grid and then by the depth of soil that needs to be removed. For example, in grid sheet 2, 5 meter width times by 5 meter length times by 1.90 meter depth will equals to 47.50 cubic meters. Then, repeat all this calculation for each grid and calculate the overall total excavated area that need to be removed. Lastly, for the filling work described under code F312.17, it involves adding general imported material, primarily granular soils like sand and gravel, to reach the proposed level. The calculation is done by multiplying the width by the length of the grid and then by depth of soil that need to be added. For example, in grid C1, 5 meters width times by 5 meter length times by 2.10 meter depth will equal to the total area of 52.50 cubic meters. So that is all for the measurement of work.
Finally, step 5 is build of quantities. There are a list of following steps that has been stated in this slide. So now let's look at each of the steps details. First, prepare a spreadsheet. It will have columns for item number, description, unit of measurement, quantity, weight unit price, and total cost. 2. Break down the work. Divide the project into smaller, more manageable work units or phases so that it's easier to identify and quantify the materials and labor required for each stage. Third, list and describe items. For each work unit, list all the materials, labor categories, and potentially equipment needed. Fourth, quantify each item. Carefully determine the exact amount of each material, labor hours, or equipment needed to complete each work unit. For step 5 and 6 is an optional items. You may include or not include it. Final steps will be review and refine. Once you completed the BOQ, thoroughly review it for accuracy and completeness. Ensure there are no missing items or errors in the quantities or descriptions. So that is all the steps for build of quantities. To conclude, this video evaluates students' understanding and application of earthwork calculation principles, particularly the transition from traditional methods to modern approaches like MyCESMM2. It also explores the challenges of traditional measurement methods and the potential benefits of utilizing video production in education. Additionally, the video emphasized the importance of accurate calculation steps, the significance of collaboration, and the potential for leverage in the dissemination of construction-related knowledge.